Hi everybody, and we're a couple of minutes past, so we'll get started. So my name's Stephen Dickens. I'm going to be co-presenting with my good friend, who I met maybe 45 minutes ago. So we're going to talk to you a little bit today about IBM's systems and how they're underpinning open source, both in the public cloud and on-premise for our clients. So I'm going to start by positioning a little bit around what IBM does in the open source community. I'll give you a personal perspective on this. I had the pleasure back in early 2015 of working with the Linux Foundation to establish an open source collaborative project under their structure called the Open Mainframe Project. And it's been a personal journey for me over the last 3 years to understand, really from an IBM perspective, how we embrace the open source community. So as part of launching that project, IBM donated 70,000 lines of code that we developed and put those up on GitHub in order to encourage the community to engage. We'll be making a few announcements as part of this project in the next few months around further code contributions. So it's really, for me, brings home how IBM looks at this community and looks to engage with the Linux and open source world to really make a shift in how we engage and how we look to bring those developers in onto our platforms and really sort of drive the conversation forward. So I'm going to spend the next 2 or 3 charts kind of setting the scene, giving you some of the perspective of what we're hearing from the industry, what we're seeing, and some of the challenges as we engage with our clients. So I think the world has changed, and the world's changed over maybe that last 2 or 3 years. So I'm not going to speak to the data points on here, but I think all of us would agree that we're seeing a frequency of data threats we've maybe not seen before. You know, the interconnected lives we lead, the mobile devices, the way we share our information, the trade-offs we make with social media providers for our data. The world is a more complicated place than it was even 2 or 3 years ago. And if you're speaking to the CIOs and CTOs and CISOs that IBM does, the consistent theme that comes back is the paranoia and fear that they have about their corporation's data. Keeping that secure, but also being able to operate in an environment where they're needing to provide more connectivity and more APIs into their back-end systems. So if you look maybe sort of 10, 15, 20 years ago, you'd have a system of record, which would be within your firewall. You'd be able to see, go up and touch it, and it would connect to things within your corporation. I think gone are those days. Anybody who's using their phone to do mobile banking expects that they can go and check their balance and it be a couple of clicks away. That, if you think of that from an infrastructure point of view, you're putting a mobile phone connected directly to a system of record. From an IT perspective, you're having to get your head around providing open access over a mobile network from a device you don't own as a corporation to your system of record, your back-end system that holds your most critical data. That keeps CIOs, CTOs, and CISOs awake at night. And they continually speak to us about some of these challenges. I think the mindset has changed where they're more likely to have a breach than not have one. So it's not planning for an event that you don't foresee, it is planning for an event that you know is going to happen. How do you think about technologies to enable that type of world? Being able to put bigger walls in place to stop people getting in is not going to be enough. Other areas we hear of from our CIO and CTO interactions is the cost of downtime. I worked with this and a client who had a 6-hour outage on one of their core mission-critical systems, and trucks backed up onto the freeway, produce in their stores and in their warehouses, and it took, from this 6-hour outage, it took them 3 weeks to recover. This, fortunately, was described by the CIO as a once every 15-year event for them, but the business impact was huge. One of the key points up here in the right on top left-hand corner as you're looking at it, for me, is the single biggest reason now for people changing their bank has got nothing to do with the banking products that they get from that organization, nothing to do with the interface when they walk into a branch. But if you don't like the app on your phone, that's the single biggest reason of why you switch banks. So consumer mindset and this consumerization of how we engage with corporations has changed the landscape for CIOs and CTOs. So just to sum up some of the points here, one of the ones on the left-hand side as you look at it here, of the 9 billion records breached in 2013, only 4% of those were encrypted. So you're planning for an event that's going to happen. People are going to get in and get your data. What can they do with it once they've got it? Why that statistic is only 4% kind of astounds us within IBM. Why are we still building systems where we're accepting of some of these types of dynamics? So we at IBM think there's a different way to approach this for some of these Linux and open source workloads. So I'm going to start to lead up now and tell you a little bit about a solution from IBM that we feel is perfectly positioned for the types of workloads, including blockchain, including some of these data serving type workloads, and some of the open source workloads and some of the partners that you see on the expo floor. As I talked about security, people are going to get into your network. Gone are the days where you can sit there thinking that they're not going to get in. So how do you plan for the event when they are going to breach your networks and those early stages of your security, and they're going to get to your core records? How do you also ensure that those people who've got access and actually are system administrators are able to be secured and that they're not walking off with your data? So as much as 30 to 40% of the security breaches are coming from inside with people you've given the credentials or the godlike access rights to your systems. So how do you plan and administer around that? So we've developed a system which I'll talk about in a few slides' time that provides the capabilities, unique capabilities built into the hardware for us to pervasively encrypt your data and then provide an environment where even people with privileged access aren't able to get to that data, and if they are, all they're getting access to is encrypted data. So unique capabilities within our hardware that I'll talk about as we go through that stop some of these issues. Also being able to do that at a scale that is built for some of these IoT and mobile type workloads that drive different characteristics. Obviously, a lot of people are looking to deploy NoSQL type database structures now, something like a MongoDB. Now, there's ways in which you can do that. The traditional way on x86-based commodity hardware is to shard that database, split that database up into various pieces, run those on separate compute nodes, and present a lot of parallel compute power to the task of running a database. We at IBM think for certain workloads, there's an alternative approach. Being able to provide that scale-up capability for a MongoDB database, and in some of our benchmarks, run that at up to as much as 17 terabytes with really good throughput and response times without that need to shard, without that need to split the database across multiple compute nodes. So what that's doing is delivering you not only cost savings, but also simplifying some of your database administration. So as we talk to some of the clients out there, what we're seeing is one of the big challenges that they've got is their commodity x86 server farms have grown and populated now to a point where administration and cost is a key concern. Our friends at Red Hat and others in the expo hall are selling tools and capabilities in order to manage that complexity. Fantastic tools, recommend certainly the Red Hat ones and others, but there's other ways you can come at this challenge. Managing less physical servers makes the job easier. So what we do here is we take an approach with a different hardware technology that enables you to consolidate and conservatively at a 10-to-1 ratio. So what does that mean from a TCO perspective? Well, let's pick on our good friends at Oracle. It's always good sport in an open source community like this. So let's pick on those guys for a moment. Classic Oracle database lists prices for 2 cores on x86 at $47,500. You then add up on top of that data guard, rack, and the encryption software. You can be up at $60,000, $70,000 for 2 cores of x86 pretty easily at list price. So say you got a great deal from Larry and you were able to get that for, say, $40,000 for 2 cores. Now you want to run it over hundreds and thousands of cores in your environment. As you can see, the cost's going to add up. What we do is we take a radical approach to simplification that says, run that same Oracle database and do it on a 1/10 of the cores. So when you're paying $40,000, $50,000 to run that for 2 cores of x86, and we can take tens of those cores and consolidate it onto one of our cores, it's not hard to see how a TCO case would tumble out of that. So what have I been talking about? I've been talking about IBM's Linux One range of hardware. So we've got 2 flavors here. The Rockhopper, if you want to take a look at one of these without the door on, is down on the IBM booth, downstairs in the expo hall. And then we've got the larger machine, our Emperor 2. Both of these are unique chip architectures. Both of these take a very different approach to how we build for scale, performance, availability, and security. So being able to take a different chip architecture and build unique hardware capability enables us to come at some of these open source workloads in a very different way. So we're not taking the approach of a HPE or a Cisco or a Dell or a Lenovo and taking Intel, ARM, or AMD chips and building from those. We're taking IBM created chip architectures, surrounding them with a huge cache footprint, different memory structures to be able to provide a system that we believe is the most optimum system for some of these large data serving and particularly encrypted type of workloads. So just to give you the run through some of the hardware, 2 different systems, 2 different core counts, 2 different memory footprints. Basically here, what we're looking at is you make choices depending on where you want to go from a scalability performance perspective to navigate through which box you go with. So that this session's not a complete bait and switch and I didn't get you in here with the cool word blockchain and then not talk about it, because you were obviously thinking that. I'm sort of 10 minutes in and it was in the title and I haven't talked about it yet. So I'll talk a little bit about blockchain. So when IBM was choosing which server infrastructure would support our blockchain instance in the public cloud, we obviously had choices. IBM makes Power Systems, IBM makes Linux One, and obviously in our IBM Cloud we run x86. So we had choices. All of those would have been IBM approved choices. All of those would have been things we could have navigated through. What did we decide to do? We decided to put our blockchain service running on Linux One. Why did we do that? Purely from a security and availability perspective. If you're going to remodel your supply chain to leverage immutable ledger technology such as Hyperledger, you're going to need to do that on a platform that A, never fails, and B, on a platform that's designed for security. So IBM was taking this forward-looking view to say, yes, 3 or 4 years ago when we made this decision, clients were still playing with blockchain as an enabling technology and hadn't made that transition to some of their enterprise deployments. But they were going to get there, and this was going to be transformational for how they run their business. So we wanted to build our blockchain deployment on this technology. What we've seen is now clients are also wanting to take a hybrid approach to how they deploy blockchain. For certain regulatory environments, for certain workloads, people are going to want to deploy blockchain on-premise, and they're also going to want to deploy that in the public cloud. So here's an example of Beijing Institute of Technology, who were one of the first clients to work with us to deploy the Hyperledger Fabric on a Linux One, download the Docker certified images from IBM that we support and provide a support contract around, and deploy that on an on-premise Linux One infrastructure. You're going to see some more from us later on in the year around building that stack with what we call IBM Cloud Private. But today we're able to be in market offering a certified Docker image of the Hyperledger Fabric running on Linux One to provide a blockchain environment for you. So I just want to talk a little bit more briefly and to give a segue into my colleague Doug around a really good use case. So I got a chance to spend some time with Graham and the team at the Met Office and really understand what they're doing. So these guys provide weather forecasting and updates to 400 external agencies and clients within the UK government. So if a submarine commander wants to know what the weather is like, they're getting that weather forecast from the Met Office. If a trucking company wants to get a weather forecast, they're also getting that. So the BBC gets its weather forecasting from the Met Office. So these guys, not only doing the complex weather modeling, they're also doing the delivery of that weather data to blue light services, emergency services, the military, and also commercial customers. So from their point of view, whilst they run that modeling on a high-performance compute environment, the delivery of that data is absolutely crucial. Making sure that that submarine commander or that ambulance service has got that data in a timely manner is absolutely crucial to their mission. So as they were moving and making the transition to open source and how they deliver that data out, they were looking for a platform with quite unique characteristics. They were looking for a platform that not only scaled, but also provided security and availability. So they surveyed the market and looked for what was the best technology they felt in order to deliver that, and came to the conclusion that Linux One was the platform. So for that delivery of that weather data, they chose Linux One. As I transition to Doug, the other key part of this story is the sheer volume of data that we're talking about. And Doug's going to pick up from me now and talk about how IBM, from a storage point of view, is handling some of that scale. But I think as I exit from this chart, I think the thing to take away is we've got a system that's designed for quite unique characteristics around performance, availability, security, and scale. And then when married to our storage systems, provides quite a compelling offering for our clients. So Doug, without any more to do, I'll hand over to you.
Thank you, Stephen. Just a little trivia about Stephen. He's a massive Star Wars fan. And if you haven't seen it, we've got a little Death Star speaker sitting down in our booth. And you've got to grab these, fill them out, drop them off down at our booth, and we'll have a drawing at 6 o'clock today for one of the Death Star speakers. So grab a card on the way in, the way out, figure your way through it. What I really love about the way Stephen talks about this is we gave you two cases. One that was truly mission critical, right? Blockchain, everything that's going there. How do you actually have highly available, highly encrypted, very secure environments? And then the Met Office, which is actually starting to look at new types of workloads and doing data modeling that actually spans the x86 environment that they have there as well as their Linux One environment. And when we think about storage and how we serve the markets, we serve multiple markets, and we serve the IBM markets, and we serve the x86 markets, and all of our storage works across the board. We're actually the #1 software-defined storage company in the world, at least according to IDC. And we have the most mission-critical systems to hook up with the Linux One, and we have some of the most innovative systems so you can scale it out. And those also work with the Linux One environment. So let me walk you through a little bit of how you walk, what you can do in this environment. Unique to the Linux One platform is the Z hyperlink in space. You're talking about 16 microseconds worth of latency here with an all-flash storage portfolio to absolutely be able to serve the kinds of workloads that you need. If you need a data monster, something that actually responds, can build, which you can bet your business, to take riff off of Graham's quote, coupling the DS8000 line with a Linux One is probably the most peace of mind you could ask for. This is built from the ground up to be mission critical, 5 nines excess of, and is available to you in all flash or in a disk environment. Keep an eye out as well, because you were hinting about the announcements that are coming out. We're going to have some wonderful announcements in this space as well for this summer, as we look at the NVMe roadmap that we're going to continue to evolve in the storage space we've been talking about for the last year. The latency goes down, the reliability goes up, and this is a perfect environment where you're thinking about those mission-critical spaces. And blockchain is a great example of it, where the data has to always be secure, always be written, and always be available. We do also look at this from a storage point of view about how much intelligence the storage can bring to you. So we have been adding to our DS8000 and our tape lines and the whole environment of the IBM portfolio the ability to offload data to the cloud. You can take snapshots off of the DS8000s and be actually able to put them in public cloud. You can put them in IBM Cloud, you can put them in Amazon, you can put them in other places. What we're looking for here is a way to integrate into the way you do business. You need to have a disaster recovery solution, and storage is actually now getting to be smart enough to be able to do a lot more of that for you at a lower cost. And we refer to this within our portfolio as our transparent cloud tiering. And we've rolled this out across the board, I think, about 6 or 9 months ago. And it's really being an excellent example of being able to have the storage offload and be able to provide additional value to you. So think more about these integrated systems. That 16U in the Rockhopper 2 might be able to fit a nice solution there. End-to-end encryption is critical. We're talking here about from the ground up, the systems were designed that way, and so are our mission-critical storage that is designed to support Linux One. The encryption goes all the way through. We are able to secure where it is on the data. If you pull a disk out, the disk is absolutely useless. It conforms with regulatory requirements for proper disposal. All the things that you need to be able to secure from end to end and have your storage be able to ensure that you are fully compliant. You don't want anything stolen. Most of it's internal. You really need to start with a great base as you're looking at the operating system, understanding how the environment is going to work and all that comes with the Linux One platform. But for the other data that you might also be using in here or other places you could store it, we give you a secondary level of encryption and a secondary level of security that is available to you. I haven't talked about tape very much, but one of the things that's also true, and certainly as you go around the world, tape is a critical backup and recovery system. It's also a critical archive system. In certain regulatory industries, you actually have to have a tape backup in certain countries to be able to ensure that data is always available and you can recreate stuff. So, of course, our tape libraries all also work with Linux One for super fast offload and archiving. I'm going to shift gears here a little bit. We're going to run through this fairly, and talk a little bit more about what the Met Office kind of environment is. So if we're talking about that mission-critical piece, the invest area with the DS8000 lines and with the tape libraries, on the more sort of mixed-use workload, where you're thinking about putting in new workloads, running things that are open source like Spark, TensorFlow, or others that you can run in the Linux environment on a Linux One, you're now also looking at how you're going to data share. Because there are different workloads that work on different environments. If you are doing something that's heavily AI-oriented, TensorFlow or something of that sort, you're going to be wanting to pull unstructured data, be able to ship it off to GPUs, do AI work. And so what we look at from the IBM storage point of view is how do we make it easy for you to have a great density of data access, that is lots of people using it, so very high performance, and to a single namespace so you don't have to move data around. When we start talking about how we couple up with a Linux One environment, Spectrum Scale, which was a software-defined storage, is probably the simplest and most economical way to do it. It's the most high-performance file system out there. It is the backing file system for the new DOE supercomputers, Summit and Sequoia, which will be announcing out here in June. It scales to literally exabytes of data, 2 times 10 to the 99th or something. And if you want the real specs, go look them up online. Don't quote me. But it is also the granddaddy of the software-defined storage business. It is actually 25 years old. And started out as being able to share movies. And now what we're looking at has been really radically redesigning it over the last 2 or 3 years to really work well on Flash, very small file systems, and has become the underpinning for a lot of our AI reference architecture. So if you're thinking here about where you're going to go next with your storage, a software-defined storage portfolio that works with Linux One may be something you want to take a look at. I do want to reiterate, really at its core, mission-critical, raw copper, Emperor 2, delivering you, 2 million IOPS off of a raw copper, more than that, some order of magnitude larger than that on the Emperor 2s. The DS8000 all flashes are your mission-critical solution. But as you look at being able to integrate Linux One into your storage portfolio, we offer this for you as well. It will run on practically any storage. It will run serve to practically any client. It will run protocols of file, object, and iSCSI. It has a connector for HDFS, so if you have a desire to be able to put Hadoop environments or Spark in order to do data translation or ETL, it's all available to you. And it, of course, has transparent cloud tiering, as do the rest of our portfolio. One thing about this, it is a parallel data file system. It stripes data across different environments. It's one of the reasons that it's high performance and scales so well and so easily. It can restripe data depending on where you want it to be, and has been really radically changed over the last couple of years to have a nice, easy UI and interface. We can deploy it in all sorts of different ways. We can deploy it fully across multiple sets of systems, or we can do it in what we call a network shared disk model, where you actually serve out protocols to it. Or you can share it in full POSIX compliance. That is, it just appears as a mounted file system. And the reason this is important is because when we start talking about integrating a Linux One into your storage portfolio, there's a couple of ways to do it in a way that's both mission critical and sort of highly available, and very fast access for the Linux One portfolio. Take a look at it. It is not your father's GPFS. We've been developing this thing like crazy. It's really got a fabulous roadmap to it as we go forward as well. Oh, something got dumped on my slides. Well, let me talk backwards a little bit about this. So the other two things that I want to talk about with this is when we really talk about what happens in the Linux One environment, you can take and set up a network shared disk model. This can also be done as a stretch cluster across 2 Linux Ones that are fully available, automatic failover between them in a read-write or an independent reader, independent writer kind of configuration. Once you have actually set this up so that you have high performance into the Linux One environment, you also can export that to any x86, any power, any cluster you need it to be. So the ability to be able to take a space like the Met Office, although this is just being open, this is not the environment that they currently run, but it's one of the options that they have, which is they've got a very large x86 cluster where they do the weather modeling. But it's that critical transactional data, the information that comes from those models, that they need to move over into the Linux One environment as part of their database. How do they securely and reliably serve that data up? Because that is the mission-critical piece of it. And the ability to share the same piece of data, be able to write it across transparently so that you can actually set up workflows, is one of the reasons that we are so hot on what happens in the software-defined storage space. IBM software-defined storage is actually underneath almost everything we do. So that DS8000 series has very specific, very tight software in it that's really tightly coupled in order to deliver a very high performance and a very high level of reliability. But as we go out, what we've learned from that space and cascade that out to our Spectrum virtualized platforms, which are all block, or to Cloud Object Storage for our object space, or to Spectrum Scale for file, or the new Spectrum NAS, which allows you to do file serving of all sorts, you end up with this fantastic environment that can span whatever your use case will be. So whether you decide to go back and invest into a more reliable space and think specifically around the DS8000 space, or looking forward into a more software-defined storage world about where you're going to work on new environments, IBM has actually got you covered. One last thing about IBM storage portfolio. I mentioned it's software defined. And that means that you can run it on x86, most of the portfolio on x86 servers. Many of them we support on Power servers. You can run it with a Linux One server for these environments that we're fully certified and tightly coupled. But you can also purchase them, the exact same software, from IBM as a storage system. So in the case of Spectrum Scale, we have something called the ESS, Elastic Storage Server. It's a pre-configured, highly engineered environment with with InfiniBand as a backplane, private network, distributed storage, and you can buy them as small as an all-flash system at sub-100 terabytes, or buy them to 4 or 5 or 6 or 7 petabytes worth of storage. And we deliver those sort of pre-configured, fully supported, and ready to go. In the same way, we look at our block storage, like Spectrum Virtualize. You can also buy that as a StoreWise portfolio, which you may know very well, or the Flash System 900 portfolio, so if you need an all-flash space for high performance. Regardless of where we go, we're delivering to you high reliability, tremendous flexibility, innovative solutions like transparent cloud tiering, and we're delivering that to you in the way you want to consume it. And with the piece that you trust IBM for, which is we do stuff that's really big, we do stuff that's really mission critical. And the couple of the Linux One solutions with the IBM storage solutions is probably the most robust platform you could have for the data that matters to you. And we've tried to make it easy for you as well to be able to share that environment within your storage portfolio, because this should be integrated into the way you move forward. So with that, Stephen, I will say thank you. We've run through this a little bit faster than I'd planned. But we're around and very, very, very open to questions and comments.